Okay, so we were on the second page of notes. We talked through these, and I believe we were here. Is that correct? Alrighty, so this says, the table above provides data for 8 ordered pairs. This doesn't have a real world situation. It's just X and Y. Here's some data. We don't know what it means. It doesn't really matter. Says which function type best models the data in the table, linear, quadratic, or cubic. Remember, those are our only options right now. We will get to some of the others. And then we're going to explain our reasons, or explain our answer using characteristics from the data in the table. So not just, we have to kind of explain with the table what's happening here. So when we look at our data, our X values are increasing the whole time, which is what you would expect, right? There would be no reason to put it in the table any weirder. But as you look so we're increasing from 0 to 3.4. And then when you look at your Y values, look at that and think about your Y values. Does this look like it would be linear? If this data is linear, let's think about this, then as X gets bigger, because my X is increasing this way, I look at my Y values, well, they increase, right? So if they're, whatever it is, if they're increasing, then if it's linear, wouldn't they need to continue increasing? But what happens here? These increase, and then they start to decrease, right? And I just randomly put dots up there. I think there's probably more than it's even up there. But they increase, then they decrease, right? Do they increase again from what we see? No. Is it possible that if we had more data, it could? Yes? But it's asking the data we have, what's the best model? Because if you think about this, well, first of all, do you think this is linear? No. Okay, so linear is out the window. It looks like could probably be quadratic, right? If it increased and then decreased and then increased again, then it might be cubic, right? But we don't know that. Based on what we have, we see that it increases and then it decreases. So which one makes the most sense here? Quadratic, okay. And quadratic, not only does it increase and then decrease, but when you look at your Y values, they are pretty symmetric, right? Roughly. It's not exact, but if I looked at, this kind of being the maximum in here somewhere, then, these are kind of the same, these are close to being the same, these are close-ish, right? Which if we actually had a quadratic, it would be exactly symmetric, right? But with real data, we don't necessarily expect it to be perfect, but that's why we can say it's roughly like that. So we would say something like, it's quadratic. We can say that the Y values increase to a maximum at about, so we don't know exactly where the maximum is. Could 18 be the maximum? Absolutely. Could the maximum be between these two or between these two? It's possible. We have no idea. But at around about 1.7, would you say? Or you could say between 1.2 and 2.2, something like that. At about X equals 1.7. My thoughts on the explanation of this stuff is that I don't foresee necessarily you having to write this out on a question like this for the AP exam, but it possibly could be a multiple choice question where these things are written out for you and you have to find the one that matches the best, right? So I don't want you to stress out over, should I put 1.7 or between 1.2 and 2.2? I think if you have the gist of what's trying to happen here, even if you had to explain it, you'd be okay. So quadratic, Y values increase to a maximum at about 1.7, then decrease, and are roughly symmetric. Any questions about that? Which that was one of the, when we come back here, this page here. Quadratic models, roughly linear rates of change, which we could have used that to explain it, or roughly symmetric with a single maximum or minimum. That's kind of where we're getting our explanation for that. All right, so then the next thing we need to do is write an equation for the regression. So we are going to go to our calculator. We are going to turn it on. We want new. We don't want to save whatever we have. Okay. And then what do we choose? 4. Okay. Lists and spreadsheets for 4. Then we are going to label our columns. Yesterday we did X values. If you feel like that's just way too much to type, then maybe we could do X val is fine too. I would not just put X, because that can cause some confusion with some other things we do when you have choices in lists and drop-down menus. So my suggestion is you make it something other than just X, like X values or whatever. So you can write out the whole world. Not the whole world, but the whole word values if you want. Y val. But I don't want you to get so lazy you just put X and Y. Okay, so then in that column, let's see. So go ahead and get your data in there then. 0, 0.4, 0.9, 1.2, 1.7, 0.2. 9, 3.4. And then don't get ahead of me on this because I want to talk about some things that might happen even if you totally know what you're doing that you don't even realize is happening that gives you weird stuff. So just get your data in there and stop for a second. Okay, so here's where we're going to tell the calculator what we want to do. But I had a few people yesterday, and I don't remember if it was anybody in here, get to the next menus, but then things were grayed out. And here's why. Once I typed in 2.8, I hit enter, and I am now in the box underneath it. I could be anywhere in any box, right? But if I either didn't hit enter or I did somewhere else, or if I clicked in here somehow, you see how I have that flashing cursor now? Now if I try to do anything, what it's trying to do is put something specifically in that box. And the choices I'm going to have, some of them will be grayed out because I can't put it in the table as a piece of data. You with me on that? So if that happens to you, if things are grayed out, go back, make sure you don't have the flashing cursor. And if you do, that's fine. Just arrow up or arrow down. Ooh, ooh. I don't know why my board freaks out sometimes. You probably couldn't do that if you wanted to. I probably couldn't. I don't know what's happening here. No, this is just making me mad. Well, there we go. As long as I'm, around and there's no flashing cursor, then I'm good to go. That makes sense? Okay, so that's one weird thing that could happen. All right, so now we want to tell the calculator to do its magic for us, right? And what do I push first? Menu, because that's where all my choices are for anything, right? Yes, we're using data, but we're not choosing that one. We were doing statistical things. So 4 for statistics, and then what? Stat calculations, so 1, and then what am I choosing here? Quadratic, because that's what we decided, so that's 6. Then we get here, okay? My X list is going to be my X values. My Y list is going to be my Y values. Okay, so save regression equation to F1. So last period, after we had done all this, we were on to the next one, somebody said, actually, I think we might have been finishing this one up. And he said, does it have to be F1? I said, well, it should populate automatically. He said, well, mine says F2. I said, okay, well, when we started, did you start a brand new document? Yes, I did. Okay. He said, but when I did it, I think he didn't hit quadratic, he hit something else, and then, so he got the wrong answer. So he cleared it out and he did it again. And so F2 is what populated, which is fine, as long as you know where the stuff is. Right now, everything being in F1, that we only have one thing, so it's fine. But here's the thing. Let's say that we were doing more than one, or if it said F2 and you don't know why and you don't want to mess with things, then that's when on here you might want to. I might actually go over here and go, okay, well, this is an F2, so I remind myself. Or if we have more than one thing, I mean, it's not, so I'm going to mark that out. But you can kind of label what's what. So as long as you know where it is in your calculator, you're fine. But the other thing is this. It was F2 because he had messed up and he was trying to redo it. He had the option to change it back to F1, so then it would just write over whatever was in F1, then he didn't have to worry about it. Okay, so just as long as you know where the stuff is, you're fine. So at least look at that stuff and pay attention to it so you then don't go pull wrong information out of your calculator. Okay, all right, so then we hit enter. Now, if you, also last period, I think when I was doing this, oh goodness, I was way down here when, I guess when I hit all that stuff. And so over here, this is all I could see. So if you're only on, like I'm on row 5 here, if you can't see all your stuff, just scroll up. It's telling you that it's the quadratic regression. It's telling you what the equation is, which is what a quadratic would be, ax squared plus bx plus c. Then it gives us a, b, and c here. And we have this ... here because these don't come out to perfect decimals like it did on the last one, which is fine. If we were going to actually use this equation, we wouldn't use the decimals that we can see. We would use what's stored in the calculator, but this is what we'll write down. Remember, everything needs to be correct to 3 decimal places, but my suggestion to you is that we write down 4. If we write down 4 of them, we should be correct to 3. We don't have to worry about rounding or doing anything else. So when I go to write this equation, this is it just y equals? What does my y need? A hat. So y hat equals, my a value is negative 4.8831 x squared plus 15.9580x plus 4.9956. Now remember, if we needed to actually do something with this equation, which this question is not asking us, you would never go type this in somewhere only using those 4 decimal places. This is why we store things in the calculator, right? It's fine to write this down, but if I use this and I'm not using the other decimal places that are out there, maybe my final answer isn't correct to 3 decimal places. So you never use intermittent rounding. We may write it down to answer this part of the question, but then if we actually had to use this, we would use everything that's stored and not retype numbers. Okay? Does that make sense to you? What questions do you have? We all good? Now, if I needed to, if it said, find the predicted y value when x is 47, right? What would I do on the calculator? Do I do it from this screen? What screen do I need? I could do the graph. I would do the calculator and just do F1 of 47 or whatever, and it just spits out the answer. If it gave me the y value and I needed the x value, then I think I would go to the graph and do it that way. Could you find the x value from the graph? Absolutely. I mean, find the y value and do it that way. Yes, you can calculate it that way too. There's more than one way, but we all good on all that? Questions? Awesome. All right, so flip it over. So let's talk about residuals, which is actually something, because it's the topic 2.6. This is actually in Unit 2 overall, but if we talk, we're just talking about a little teeny tiny bit of it right now. If we talk about it a little bit at a time, it won't be brand new when we get there and really get into some of the weirdness here. But just that concept of what a residual is, right? When we use a model to predict values, remember these are predictions when we have our little hats, we expect our model to produce values reasonably close to the actual values, right? It should be reasonably close. But our models are not expected to result exact values generally. It is possible that when you do a scatter plot of your data, that your regression doesn't touch any of the points, or maybe it hits a couple, or maybe just one. It just depends on the data. So the difference between the actual value and the predicted by the model is called the residual. So what a residual is, it's the actual value minus the predicted value, which means it's basically y minus y hat, and that's why we have to distinguish between the two. So we are going to use the same data we used in example 1. And I specifically told you not to save it because we need practice getting all this stuff in the calculator, right? So I want you to go back to your calculator, hit the home button, new, no, then you go from there, you get your data in there, everything labeled, and get your linear regression back without me walking you through it. If you're sleeping through what I'm saying right now, or slept through the rest of it, wake up. Or you don't remember, the first set of notes had screenshots on it, so or little screen grabs, so that you can go and look at those screen grabs. That way you know where it is if you need reminders. Make it happen. Okay, anybody struggling? I know some of y'all are still typing, that's okay. I'll give you a little bit of a minute to struggle through it there. Okay, so once we get this, we don't have to rewrite our equation or anything because then none of that's asking for that. But we want to make sure that we are at least writing down our stuff accurately and answering these questions accurately. Can I move on? Do we all have it? Because for this one? Well, because it's number 1 and we already did it, but also because as my x values increase, my y values increase, and we roughly have a constant rate of change. All right. So what I want, so this is asking me, it says, use the model from example 1. What is the residual of the baby that is 5 weeks old? Okay, so interpret the meaning. So we're looking for certain things. So we're looking for the actual value, which means I want W of 5. Got to label things correctly, right? W of 5, what is W of 5? 4.4, right? Then I want my predicted value, that's W of 5 hat, right? So that I get from this. And if I just basically want to plug an x value in, the easiest way, I mean, it's a matter of opinion, but probably it's a little bit easier to do it on the calculator screen than it is on the graph screen for this. So we're going to add a calculator screen because we don't have it. So Control Doc, calculator. And then where is my function stored? F1. Have we actually seen it in F1 today? No, but we know it's there because that's where we told it to put it, right? So F1, I literally type F1 of 5, and I get 4.47. Now, if your calculator is set correctly with the settings that we've done, then this should just be on float, right? Not if it was float 2, then this is probably the answer we would get. If it was just float like it is, this is the answer we get. So since we don't see a ton of decimal places, we know that there is no rounding. Yes, I'm supposed to be correct to 3, but if there's only 2, there's only 2, right? And so that is my answer. It is 4.47. Okay. So then the residual, remember the residual is the actual, which is W of 5, minus the predicted, which is W of 5 hat. Okay. Important to write these notations down. That shows that you understand which are the y's and which are the x's and what's what. And we get 4.4 minus 4.47. Then you still have that calculator screen. My suggestion to you, it is a calculator problem. Let the calculator do it so you don't do something ridiculous. On what I wrote down when I went through this, I don't know if I wrote the wrong thing down or my brain did the wrong thing. I have no idea, and there's no telling really. On my paper, I have 0.7. Is it 0.7 or negative 0.7? No, it's negative 0.07, clearly, and that totally makes sense. Again, I don't know if I just didn't write down the zero or if I did it in my head, but it's easy to do something simple wrong. So if you have the calculator, do it, even on the easiest addition and subtraction. What are the units here? Kilograms, right? Okay, so let's think about what this means, right? Now, we haven't talked about what a negative residual means or a positive residual, but think about what we just did. Which one's bigger, the actual or the predicted? The predicted. Okay, so is our model then, is it an overestimate or an underestimate? Overestimate, okay. So now we know if we have a negative residual, it's an overestimate, right? So then we can answer this and say, the model is an overestimate of actual values. Now, let's talk about the rest. Now, I put a graph on here for you. I didn't want you to have to do it. It's like a bazillion clicks to get here, and we don't need to be able to do this now or maybe ever, but I wanted you to see what's happening. So on mine, the blue dots are the actual data. The black line is our model that we found, okay? And so we can see that, first of all, is this model always an overestimate? No. Okay, at 4, it's an overestimate. At 5, it's an overestimate, and that's what we're talking about right now, right? At 6, it's an underestimate. At 8, it's an under, and at 12, it's an over. So I wanted you to see this so that you could understand why we can't just stop our explanation here. Is it always an overestimate? No. And what we found on this, and we can see it from the graph too if we wanted to use this as an explanation, but from what we did and what we showed in our work there, the model is an overestimate of actual values at t equals 5 weeks. Okay, so you have to be careful with general statements. Any questions about that? Because most models aren't always going to be one or the other because, the idea is that the data kind of, goes on either side of it. And again, our model didn't hit an actual single point anyway. Okay. What questions do you have? Are we good? Awesome. Okay, so both of these go on the same page in your ISN. Remember that first piece of paper has the screen grabs if you're a little unsure, but you'll get the hang of this stuff pretty quickly. I know if I handed you a brand new phone or a video game or something, you can figure it out quickly, so I'm pretty confident you can figure this out as well. Plus, we don't use every single thing in every single menu, so the things that we are using should seem familiar and you know which ones you've hit before,